So as we have seen in last class, law of conservation of energy. So today we are going to prove that a freely falling body, so like a law of conservation of energy for a freely falling body. So we all knows that according to law of conservation of energy, so what actually law of conservation of energy will says that, so the total energy before transformation, total energy before transformation, total energy before transformation is equals to total energy, speak everybody, total energy after transformation. Am I right, all of you? That is only ways to call it as law of conservation of energy. I have taught or not last class. So law of conservation of energy will says that total energy before transformation is equals to total energy after transformation. Now, if I comes to the law of conservation of energy for a freely falling body. So if you have seen that last class we have done that activity also. So that activity results also we have done. Am I right, everybody? Correct? Yes, please. So now that results we calculated. What are the textbook activities there? Have you done that calculating the potential energy at 4 meters, 3 meters, 2 meters, 1 meter? Is it right or wrong? Everybody? Yes, please. All of you?
Yes, sir.
So today we are going to prove that how it will be going to make it. So all of you keep reading law of conservation of energy. Law of conservation of energy for what body? Everybody. For a freely falling body. Freely falling body. So this is a very important derivation. So yesterday offline class I have taught you while you are calculating freely falling body. As Mr. Sam asked the question. Do you remember, Mr. Sam? So what is the potential energy? What is the kinetic energy before touching they are asking? So that is what which is equals to, I said, potential energy. Is it right or wrong? Do you remember? Yes?
Yes, sir.
Yeah, that is one. So for that, it is very simple. We have to calculate. So let me consider a freely falling body. So we all know what is a freely falling body. So if you have been done that, so let us consider a body of mass m. So write everyone. Let us consider a body or object of mass m falling freely from the height h. From the height h. Do you understand, all of you? From the height h. Okay. So let me consider everybody. So there is an object of mass m which is at initially at point A. Okay. So if it is freely falling, we all knows that. What is the initial velocity? Try to remember the concept and tell me. If it is freely falling, what is the initial velocity? Everybody. Nobody is there in the meeting. Coming down, what is the initial velocity? I'm asking you. Freely falling, 0 meter per second. Do you forget, everybody? If object is thrown up, initial velocity is maximum. After reaching the final height, maximum height, final velocity is what? 0.
Zero.
If object is coming down, initial velocity is 0. And before touching the ground, final velocity is what? Everybody?
Maximum.
Maximum. So now we are going to prove that law of conservation of energy for a freely falling body from a height h. So let me consider, now this body is falling from a height h. So let me take total height is h. All of you draw straight line. You have to draw. So this is the total height where the body is traveling. So by the time it will reach us to the what? Ground. So this is the ground. Clear, everybody? Understand, Shivani? So this is the ground actually. So now it will fall on the ground from a height h. So now total height is h. So at this point, let us calculate the conservation of energy. What is conservation of energy for us? All of you remember, mechanical energy is equals to what, everybody? Kinetic energy plus potential energy. That is what? Half mv square plus mgh, which is equals to mechanical energy. Means at every point, sum of the kinetic energy plus potential energy equals to mechanical energy. That is what is our point. Now let us consider at point A. Let me take this is the point A. So what is the mechanical energy? We'll calculate first. So all of you write at point A. So let me take it now. At point A, right? So what is that? Body is at rest. Am I right, all of you? Body is at what? Please respond. Body is at rest. Rest means what is the initial velocity? Everybody. Velocity?
0.
If velocity is 0 means at that point, what is the kinetic energy? Kinetic energy half m u square. So u is 0. So that kinetic energy will become what? Kinetic energy will become what? Everybody.
0.
0. Understand, everybody? So as the velocity is 0, kinetic energy become what? Speak loudly. Kinetic energy become 0. Now, and this object is present at a height of h. Object is present at a height of h. So, what is the potential energy? So, potential energy is equals to, what will happen, everybody? mgh. Am I right? Speak, guys. All of you? Yes? Yeah. So then, mechanical energy is equals to, what is the mechanical energy, all of you? Mechanical energy is equals to, that is what, let me take E is equals to kinetic energy plus potential energy. So mechanical energy, what is the kinetic energy, everybody? 0. Yeah, potential energy is equals to what? mg. So what is the mechanical energy? E is equals to, mechanical energy is equals to what, all of you? mgh. Am I right? Speak, guys.
Yes, sir.
That is it. So at the maximum height, mechanical energy is equals to mgh because kinetic energy initial velocity is 0. So that kinetic energy is 0. Now, the body started falling towards to downwards. So it is travel a distance of something x. Total height is h. So now it is travel a distance of x. Do you understand, everybody? And that is the point I'm taking a point B. And the next point, it will reach us to the ground. So before reaching the ground, I'm taking as a point C. Before reaching the ground, I'm taking as a what, everybody? Point C. Do you understand, Amma? All of you? Please.
Yes, sir.
Yeah. Before reaching the ground. Before touching the ground, I'm taking as a point C. Now you tell me, if the total height is h means, at the B point, I'm taking as a point B, I'm taking as a x distance travel. Then remaining distance, how much? From B to C. Anybody? What is the remaining distance? Total distance. And this distance,
H minus M.
what is the remaining
I
distance?
mean X.
H minus x. Correct? Please mute yourself. Somebody is making. So h minus x. Do you all understand, everybody? This one? Please respond, guys. All of you?
Yes, sir.
Now, and one more thing. When the object is coming down, the velocity keep on increases or decreases? That is what is my another question. Everybody? When the object is coming down, as we know, initial velocity is 0. So now, suppose I check at this point. Definitely the velocity is more or less up. Let me take V1. Here I'll take V2. Before touching the ground, V3. So which is greater? V1 is greater or V3 is greater? Everybody? Yes, please. Respond, guys. V3 is greater. Understanding? So as we are coming down, velocity is going to increase or decrease? Everybody? Velocity is going to increase. Now, let the velocity at this point B is V1. What is the velocity, everybody? What is the velocity? All of you. V1, I am taking. So at point B, all of you write it. At point B, let V be the velocity of the body. Write it. Let V1 be the velocity of the body at point B. At point B. Displacement covered. What is the displacement covered from A to B? Speak loudly. See the figure and tell me. What is the displacement covered from A to B?
X.
Yeah, that is what. Displacement covered by the body from A to B. A to B, H is equals to X. Then there is no time is there. Initial velocity is 0. Only speak about A to B. Point A and point B. Here initial velocity is 0. Final velocity is V1. And the displacement traveled is S is equals to X. So which equation we can use, guys? Anybody can tell? We can use some equation to calculate the V. Anybody can tell? What is the equation you use? Equations of motion. Anyone? Respond, guys.
V square is equals to U square plus 2S.
Yes, which equation you can use? That's what is my question. Anybody? Speak loudly. Yeah.
The third equation.
Third equation of motion. Yes. So, by using a third equation of motion, right? What is that? Using third equation. So, why I'm using third equation here? Because we want to find the V1. Am I right or wrong? What is this velocity? If you want to calculate the kinetic energy, we need to know velocity. Am I right or wrong, guys? Yes or no? Yes. So, third equation of motion. So, what will happen? Final V square minus U square is equals to 2AS. So, what is the initial velocity, Shivani? Initial velocity is 0. Final velocity is V1. So, V1 square is equals to 2 into A value what? A is equals to freely falling. A is equals to something. What is that? G.
G.
And S is equals to X. So, V1 is equals to, or V1 square is equals to 2GX. Will you all agree with me? All of you? V1 square, not V1. V1 square is equals to 2GX. Now, at point B, what is the kinetic energy at point B? All of you. Formula, tell me. What is the kinetic energy formula? Kinetic energy at B point. What is the formula? I'm asking.
Half mv square.
Half mv square. So here V means what? V means what? V1.
Velocity.
V1 square. So V1 square is equals to something. Verify it. What is that? V1 square is equal to, hey, who is that making mute? V1 square equals to something. What is that, everybody?
2gx.
2G. So half into M into, in place of V1 square, I can write what? 2GX. Do you understand, everybody? So 2 will get cancelled, which is equals to, what is that? Kinetic energy at this point equals to how much? Kinetic energy at this point, which is equals to mgx. Next. Now, potential energy at point B. Potential energy at point B. Now tell me, potential energy always will calculate how? The position above from the ground. Am I right, everybody? The position above from the ground. Is it right or wrong? Yes or no? Yes or no? Everybody.
Yes, sir.
So can you tell me, from the position above from the ground, what is the height present at now? Anybody up to here? What is the height present? Body.
H minus x.
Body is present at what height? All of you.
H minus x.
Minus x. That is what. So height of the body. Height of body at B from the ground. From the ground. is equals to, what is that everybody? Speak loudly. H minus X.
H minus
Understanding? So, potential energy at B is equals to, what is the formula, everybody? At B is equals to, what is that? mgh. So, H is equals to what? H is equals to what? H is equals to what from the ground?
H minus X.
Minus X. So, means mgh minus mgx. Am I right? All of you? Do you all understanding? Any doubt? Anybody can ask. Okay, guys?
Yes,
That is next. So what is that now? Mechanical energy. Now, total energy or mechanical energy, ma? Both are same. Mechanical energy or total energy. Total energy at B is equals to, so what will happen, everybody? E is equals to kinetic energy plus potential energy. So at point B, what is the potential kinetic energy? We have calculated mgx. Correct, amma? And potential energy is what? mgh minus mgx. mgh minus mgx. So if I remove the bracket, it will become mgx plus mgh minus mgx. So what will happen, everybody? mgx will get cancelled. So what is the total energy at point B? Again, we got it. mgh. Do you understand it? Yesterday, I have taught you the question. Do you remember anybody?
Yes, sir.
So same thing. So whatever the energy lost in the form of potential energy, see from A to B, whatever the body lose the potential energy, which is equals to the kinetic energy gained by the body. Do you understand, everybody? The potential energy lost by the body, which is equals to the kinetic energy gained by the body. Because we all know law of conservation of mass will says what? Law of conservation of energy. Energy neither be created,
nor be destroyed.
energy neither be created nor be
Nor
destroyed.
be destroyed.
So always the energy transformed. So energy, total energy before transformation is equals to total energy after transformation. So it has been proved. Am I right, guys? Everybody? Yes?
Yes, sir.
Now, only see from A to C, final point. At C, midpoint, you have to forget it. See, when we are studying at B point, we have to see only A to B. Now we are going to study at point C. At point C. So at point C, all of you observe. Motion of the body, you should take it only from where? From the initial. So motion of the body from the initial. What is the initial point? What is the initial point? What is the initial point, Ra?
B.
B. B is a midpoint. We don't bother about it. Only we always will consider from where? From A. Do you understand? So A to C. So motion of the body from A to C, if you consider. So we'll take. Now, whole journey you have to consider. Midpoint is only for our observation. So now A point and C point. Now tell me, what is the initial velocity? 0. Before touching the ground. Before touching the ground. What is that, everybody?
Maximum.
Maximum. Let me take that velocity is V. Okay, everybody? Then, what is the total distance traveled? What is the total distance traveled, everybody?
H.
H. Okay. Now, you all see. Right. Let V be the velocity at point C when the body touches the ground. When the body touches. See, after touching, what is the velocity? After touching, what is the velocity? 0.
0.
Understanding? So that is you should remember. Then S is equals to H. Initial velocity is 0. So now which equation I can apply here again? Initial velocity I know, final velocity I know, and height is equals to H. So what is the equation I have to use it? Anybody? No time is mentioned. Using which equation, guys?
Third equation.
Using third equation. Using third equation of
D
motion.
square minus U square.
Yes. Everybody has to involve. That is what? V square minus U square is equals to 2AS. I can write it. Yes. V square minus U square is equals to 2AS. So initial velocity is 0. Final velocity V is equals to V. So V square is equals to 2G. G value is what? A equals to G. Okay. So G and S is equals to H. So V square is equals to 2GH. Now, from that, what is the kinetic energy at point C? Everybody. Kinetic energy at point C. At point C is equals to what? Formula, tell me. Kinetic energy formula, half M V square. So half into M into V square means what? Everybody. V square
2GH.
2GH. So 2 will get cancelled. So what is the kinetic energy? What is the kinetic energy? mgh. Now, at point C, next ground only. At point C, what is the height of the object above from the ground? Anybody? What is the height of the object above from the ground? It is almost touching the ground. So what is the height at point C?
0.
You understanding? So at point C, the body is about to touch the ground. So what is the potential energy? Height above from the ground is 0. So that what is the potential energy? Anybody?
0.
0. So from the ground is 0. So potential energy at C, potential energy at C is equals to what? Everybody. Speak, respond, everybody. EP is equals to mgh. So where h is equals to 0, so that whole potential energy will become what?
0.
0. Understand, everybody? So that is what. So now total energy. So our mechanical energy. So total energy E is equals to kinetic energy plus potential energy. So kinetic energy equals to what? mgh. Potential energy is equals to what? 0. So that what is the total energy? Everybody. Total energy at point C. Everybody? At point C, what is the total energy?
0.
0. Yaar 0. At point C, total energy, girl. What is the total energy at point C? mgh. Understand? Potential energy is 0. Kinetic energy is there. So total energy. So at every point, at point A, point B, point C, what is the total energy? Verify it, everybody. mgh. Total energy is what? mgh. Total energy is what? mgh. So everywhere, energy remains. Energy remains conserved. Do you understand, everybody? So everywhere, if you notice it, energy, we see that the mechanical energy or total energy of the body is same, and that is equals to the mgh. Now understand, Sam, how to calculate it? Do you understanding, everybody? So at every point remains it is same. That is why we will say. So if the frictional force is neglected, that is also very important. If the body is freely falling, it will experience the friction of something. Anybody can tell what is that? If the body is freely falling, it will experience the friction of something, air. So that is very important. So please note it. If frictional forces are neglected, if frictional forces are neglected, understanding? The mechanical energy of the body is same. The mechanical energy or total energy of a freely falling body at every point is remains what, everybody? Remains same. That is what you have to remember. Understand everyone? Clear everybody? So this is only call it as, what we used to call everybody? Verification of law of conservation of energy. Please write it. So this is a proof you have to write in exam. Suppose they ask verification of law of conservation of energy. So you have to do this one. Do you understand everyone? Please respond. Anybody cleared out? You can ask. So it's a very simple derivation, but it's very important derivation. So at the lowest point, the total energy is only kinetic energy. At point A, the total energy is only what? Everybody. At point A, the total energy is only what energy? Speak, guys. At point A, the total energy is what point? The total energy, which is equals to potential energy. At point C, lowest point, total energy is equals to kinetic energy. That is what you have to remember. Understand, Ra? Everybody?
Yes, sir.
Yeah,
Yes,
that
sir.
statement is very important. Write it. At the highest point A, at the highest point, A, total energy is only the what energy? Only the potential energy. Do you understand, everyone? Next, at the lowest, what is the lowest point? You take 100 also, no issues. At the lowest point, what is the lowest point? C. Understanding? Total energy. What is the total energy? Which is equals to something. Only what energy? Only the what energy, guys? Yeah, what are you people nonsense? What is point C? What is the total energy? Total energy equals to what energy?
Kinetic energy.
Kinetic energy. What you are solving also you are not able to say, then what is that? Next, what about that point B? At the point B, if you have taken, the total energy is what? It's a mixture of both. What is that energy? Total energy is partly potential energy and as well as partly
Kinetic energy.
kinetic energy. Partly potential energy and kinetic energy. But remains energy is what? Total energy remains. Total energy remains conserved. Total energy is conserved. At every point, the total energy is remains what, Amma? Conserved.
Conserved.
Okay. Please write it. So this is only the verification of law of conservation of energy, as I told you. So please learn it. It's very important. Then let it be. So finish it. Anybody having anything doubt, you could ask me. Then you can see regarding this in H1 book. So all of you are having H1 book. So take your H1 book. Completed this one. Derivation understood or not? Yes. Everybody, be able to do the derivation? Please respond.
Yes, sir.
Yeah. So if you have been understand this, then 1 minute. So you can notice in your HR book, all of you come to the page number, law of conservation of energy. So page number 160 in book. So if you are having a book, hard copy, you can make it. Okay. So just a minute. So first finish this derivation, everybody, at point B. All of you do it. At point B. Make it quick. So if you're having H1 book, take it, everybody. I think most of you are having. If you're not having also, soft copy it is there. You can go through that. So all of you open page number 160. So 160, you'll be having a law of conservation of energy. So all of you go through that law of conservation of energy. And you can see that they are dropping with the help of a crane. A big ball is dropping for a certain from a certain height. So that you can see the velocity is gradually increases gradually. So they have given a picture also. And you go through that and there is an example of it. So once you solve it, I will show you that. So conservation of energy during the free fall of a ball, they have given that. I'll show you. Now immediately after the class, you have to go through that. I think. Have you seen this one, everyone? When a ball at rest, a falling ball at point B, falling ball at point C, falling ball at point D, just before hitting the ground. So everywhere you have to calculate the energy. This question immediately you have to solve it now. So you can make it everything. If not required this one you can solve. So you can notice it how they are doing it. Okay. So conservation of energy is remains what? Conservation of energy remains same. You understanding? So energy neither be created nor be destroyed. Energy of a system is remains constant. That is what you have to remember it. Okay. So this is immediately you have to go through that and you have to do it up to here. Don't read next one. Next we will study and then only you can do it. Okay. So this is what is the derivation of law of conservation of energy. As I told you now. So keep it in mind. If anybody will ask you, calculate the kinetic energy before touching the ground. So which is equals to what is the formula? Anybody tell? Half mv square or mgh before touching the ground. Wherever it is, if you want to calculate it, you will calculate what is the energy? mgh only. Do you understand, everybody? In case of free fall, at any point, if you want to calculate the kinetic energy or potential energy or total energy, doesn't matter. What is the formula? Everybody? At every point, total energy is equals to what? mgh. Am I right, Amma?
Yes, sir.
Yes, that's all. So, before touching the ground or at the maximum height or in between the way, wherever if you want to calculate potential energy or kinetic energy or total energy, you have to remember that always formula is mgh, but h means what? Always you should take above from the ground. Clear, everybody? All of you? H means what is the height present above from the ground. That is very important. Okay. Thank you. This is what is about the today's class. So happy Sunday. Enjoy. And then tomorrow we'll continue law of conservation of energy for a simple pendulum and transformation of energies. And then we'll go with the last concept, call it as a power. Okay. So finish this derivation and learn. This is most important derivation, law of conservation of energy, verification. Here, that is what I'm saying. Verification of law of conservation of energy. This is what you should learn. Okay. All of you. Thank you. Happy Sunday. Enjoy the day.